let's continue the ambiguous case. Part 2, solve this triangle. Gamma equals to 19.5 degree, B equals to 9, C equals to 12, and solve for beta. First, we want to write a triangle. We know that gamma 18.5 degree, oh, that's alpha. Gamma 18.5 degree corresponding to the side C, and B equals to 9 and the corresponding to beta, and we want to solve for beta. To do that, we can just use sine gamma over C equals to sine beta over B. Then we have sine 18.5 degree over C is equal to 12. Beta, we don't know, leave it there, and the B is equal to 9. Cross multiply with 12 times sine beta equals to 9 times sine 18.5 degree, and then sine beta equals to 9 times sine 18.5 degree over 12. Now, I am going to use decimal to solve it. I don't feel like I need to share the screen, so divided by 12 is equals to 0.7471. Okay, the next step is we need to use the inverse function to solve for beta. So beta is equals to the inverse function. So be careful when we're doing this. Again, I'm going to use I'm using the decimal to do that. When you're using the decimals, you need to be careful to double check if this is in radians or in degree. So we solve for beta is 14.83398 degree. Actually, in fact, this beta is not the actual beta, it's the reference angle of a beta. Remember that. I'm going to highlight it. This gives us the reference angle of beta. So that means the actual beta, we have two possible solutions, since sine could be in the first and the fourth quadrant. So this is 14.8 degree, 0.33, and then this is 14.8 degree, 0.33. In the first and the fourth quadrant, because they're both positive. So we have two beta. The first beta is the one in the first quadrant, 14.83398 degree. And the second possible solution would be beta in the fourth quadrant, which is 118 degree minus 14.83398 degree. All right, let me subtract that. Equals to 131.6602 degree. So here are the two solution set, and we want to find out if this is correct. One way to do it is to find the height, see if the height makes sense, see if the height is less than or C is greater than B. Remember the case that we talked about? Is that going to be case 4 or 3 or 2? Another way to do it is to find out the third angle and check with the golden law that we talked about, the bigger angle corresponding to the bigger side and smaller angle corresponding to the smaller side. So now I am just go ahead trying to find the third angles and see what happened. So since we have a two solution set, I'm going to write it in here. So the first solution set is when beta equals to 14.83398 degree. The second set is beta equals to 131 degree and 6.6602 degree. We can simplify it by just use the whole number, But again, I still want you to keep the exact number as possible during the calculation. You can round it at the end. All right, so what else is given? Let's go back and take a look. So we know that gamma equals to 18.5, B equals to 9, C equals to 12. So I'm going to write this set in here. Okay, so right now, these three things is given. This is for sure. This is, you already know. It just, we don't know if beta 1 correct or beta 2 correct, or they both correct or they both wrong. Now, let's find alpha. The first alpha would be 118 degree minus 14.8.3398 minus 18.5. Again, I'm going to use a decimal. I got 14.66602. So now I use, usually when you do that, because we don't know if this is correct, right? You want to use the ratio that is given and that's for sure, which means we're going to use that set. Which set is known? The gamma and the C. So that means I want to use sine gamma over C equal to sine alpha, the first alpha, over the first possible side A1. So sine gamma is 18.5 degree over 12 equals to sine 14.6 degree over A, and then our A, the first possible A is 12 times sine 14.6602 over sine 18.5 degree. All right, let me calculate that on decimals. So what I found, A is equals to 8.7609. All right, now let's take a look, see if this is the corresponding one. So A is equal to 8.7069, and then alpha, I'm going to write this in here. Alpha equals to 14.662 degree, and then B is equal to 9, and beta, we use beta 1, which is 14.8 degree something something, and then gamma is 18.5 degree, and C is equals to 12. Let's take a look. Biggest angle, I should change the order, let the side be on the top. Psi is equal to 12, gamma is 18.5 degree. Okay, now longest side is 12, biggest angle is 18.5. Smallest side is 8.7, and the smallest angle is 14.6. So that means this combination work. So if it's correct, I circle it. Now let's check this one. We have a beta and the alpha. Now a gamma, sorry. Now let's find alpha. Alpha equals to 118 degree minus 131 for beta minus 18.5. Oh, this is not going to work because this is going to be a negative angle. We can't have a negative angle. So that means the second solution won't work. So that means that's the only one solution that we have. It's going to be this set. Okay, let's do one more exercise. We can also double check it before we do one exercise. Let's double check the answer by finding their height. See if the height is, if you only have one solution, you only have two cases, right? Either the second cases or the fourth one. Let's see which one is correct. Let's construct the height. So if this is the height, So the high is equal to sine 18.5 degree equals h over b, which is in this right triangle, is the opposite side h over the hypotenuse 9. And then h is equals to sine 18.5 degree times b. And then b is equal to 9 times sine 18.5 degree. Let me use a GeoGebra. It's 5.142, which is less than c. Less than c. So, well, a didn't greater than that. Hold on. Oh, never mind. We don't need to test out for h because this side, oops, I made a mistake. We don't need to do that. We don't need to find out h because this side is longer than b, so that means this is going to be the case 4, right? So that means we only have one solution, not two solutions. Again, also we check that the second solution won't work, so that means they only have one solution. All right, let's take a look at this one. In a triangle, one side had the length 4 meters and the opposite angle of 15 degrees. One has a length of 4 pm, the opposite angle is 15, and the second side has the length of 10 meters. Okay, let's construct this triangle. Triangle, one length, the opposite side. If this is 15 degrees, this is going to be 4 meters, and the second side, let's say in here or here, either way, it doesn't matter because they're the same. It's 10 meters. Now, they want us to find all the triangle, to find all the side and the angles. The first thing is we can use the law of sine. We know the alpha, and let's say this is beta. So we can use this two ratio to find out the angle beta. So we have sine alpha over A equals to sine beta over B. So sine alpha is 15 degrees over 4 equals to sine beta over 10. Cross multiply, we have 4 times sine beta equals to 10 times sine 15 degrees, and then divided by, divided by 4 on both sides, we have sine beta equals that. Let me use GeoGebra to do that. Let me cancel all of this first. So we have 10 times sine 15 degrees divided by sine, divided by 4. It's 1.9 something. So sine beta equals to 1.915. Then we know that there is no solution. Why is that? Why there is no solution? Because we know that sine, the biggest value for sine is 1. The smallest, the minimum for sine is -1. Sine is always in between -1 to 1, but this is 1.915. Another way to check it is we can use the arc to check it. So we have arc sine. If you don't remember the range of the sine, You can just use arc. I think they will tell you the same thing. See? It's undefined because it's already beyond the range, so it's impossible. So that's all the ambiguous cases for sine. I think this is matches for the first case, right? Okay, that's it for this video. See you in the next one.